My name is Taryn Packer, and I'm a Simulation Support Specialist here at GoEngineer. Today I wanted to talk to you about one of the major differences between thermal analysis in a simulation study and flow simulation. Basically, in thermal analysis, you can't do convection heat transfer between two part files, even if the gap between them is very, very small. If they're not touching and conduction heat transfer can't happen, then convection heat transfer won't happen either in simulation thermal analysis. In flow simulation, it'll happen just fine, and I'll show that to you. So I have a very simple setup here. I just have two blocks that are separated by 1/10 of an inch. Now, I'm going to go through my thermal setup. I've got a transient analysis with 100 seconds turned on for the total time and a time increment of 0.1 seconds. For my bodies, I've got them both set to copper as their material properties. For my temperature loads, I have a 70-degree thermal starting load initial temperature, and then for the bottom brick, I have a negative 35 degrees Celsius initial temperature. I also have a convection transfer on these bricks. The convection coefficient is 250 watts per meter squared Kelvin, and the ambient bulk temperature is 300 Kelvin. I've already run this study, so when we look at the results, you can see that they are very, very different, and there's no heat transfer between them. There's no heat gradient here at all, and I can show that absolutely by probing these two bricks. And I can show you. So this is essentially still at 70 degrees Celsius, and this is essentially still at negative 35 degrees Celsius, even though the simulation ran for 100 seconds. And there should definitely be heat transfer between these two bricks over a 100-second time span. So now I want to go into flow simulation. Alright, so here's my flow simulation setup. I ran the exact same physical time, 100 seconds. If I go into the general settings, I'll show you I have heat conduction in solid in an external study. I've got time dependency turned on and gravity turned on because it's a natural convection problem. My fluids I've got set to air. My solids, I have set that to copper. Both bricks are copper, so the exact same setup as my thermal study. And I've got room temperature just like in my thermal study. My initial conditions are the exact same again as my thermal. Bottom brick is negative 35 degrees Celsius initial condition. Top brick is 70 degrees Celsius initial condition. So when I show my results here, I'm going to show both the fluid and the solid temperatures. There's definitely heat transfer going on here. And if I probed these in roughly the same spot as I did in the thermal study, you can see there was definitely a heat loss in the 70 degrees Celsius block. Went down to about 60 degrees Celsius, and there was a heat gain in the negative 35 degrees Celsius, went up to negative 22 degrees Celsius over that small gap. And there's obviously all this heat coming off up here as well, so you can see what's happening in the actual fluid environment, not just in the solid environment in flow simulation. Thank you for watching this video. If you would like to learn more about thermal analysis or flow simulation, please contact GoEngineer for more information.